Here's a brief demonstration of using Carbonite Migrate, part of OpenText Security Solutions, to migrate a server running Windows 2016 and SQL 2016 in AWS into GCP. So the source system is running SQL. Definition, a lot of applications installed. You can confirm that it is running in AWS. The target system in the full server to any workflow, the targets must be built. So you would need to build a identical target, identical from a perspective of file system. So the drive letters need to be the same base operating system. You don't have to have the same storage size, but it has to have enough free space to support the application data in use plus our system state. Other than that, everything is pretty generic. Now, once they are defined to the console and license, you would select the migrate workflow. From the beginning of the workflow, you're presented with several options on migration. Since this is going full server lift and shift from AWS to GCP, you'd select the server migration. If there's any data elements on the system that you want to exclude from the replication for migration, say this is some historical data or something of that sort, you can actually exclude the whole folder from the replication set. In this case, I'm just going to use everything. Next thing it's going to ask you is, okay, just confirm the target. In this case, I only have one target in the workflow. So now it's going to look at the machine source side and going to come back with some job options. Those job options are pretty much generic. So in essence here, what's happening, we're going to wait for initiation of cutover, means it's human intervention. Upon that initiation, we're going to shut the source down. So there's no changes at all done to the source system. Now, since we're coming to GCP, it's different subnets. We want to make sure that we retain the target systems and networking infrastructure. Other than that, everything else will be replaced based upon the source. So it's going to take on the computer name, the SID, the GUID, domain and membership, and that. Now, if the Active Directory is established at the GCP location, you can actually tell us to update the AD integrated DNS. Just have to point to us the IP address of that and provide proper credentials for us to make that change. The other piece is the networking route. So since we're going from public to public IP addresses, this console is running in GCP, so it would normally see this machine using its local internal IP address. So you're going to have to make sure you change the target IP to the public-facing IP. Again, if you're having direct routes of things of that nature, site-to-site VPNs, and that infrastructure would be different as well. We have compression and transmission, so we can set the maximum in this case here, and then you also can create a quality of service, limit the replication traffic that we would use on the network. We are obviously very bandwidth efficient, so we're not going to overrun the network. From there, you click next, and the next will actually do an in-flight validation. It's going to confirm the target system is sufficient. In this case here, everything looks good. We are calling out the fact that the systems are not the same from a processor perspective and also from a RAM perspective, and that's okay with us. From here, we click Finish, and what it's going to do here, it's going to begin to create the job and begin to move data. Now, a couple things I'll show you here is that on the target system, it's going to stage the data on the C drive. So the system state folder is actually the real-time replication of the program files, documents, and settings from the source to the target. So as you see, things will grow here as we move data. What we don't do is we don't write Windows over Windows. We do our system state merge process, which is part of our cutover, which will take the data that's reside in this folder, and we then at that point in time override it. Now, as you saw as I was talking here, a couple folders just showed up. So anything other than staging will go directly where it needs to go. So in this case here, these two folders here are not system state in any straight. So same thing would happen with your application data. If it's outside the system state folders, it'll go exactly where it needs to go. So you don't have to worry about accommodating that storage. We'll give you a progression of what's going on here. It's got A to Z is a synchronization, but what's really nice about our solution, it's doing real-time replication. So as changes are occurring on the system, it's going to transmit the data from source to target. Now, since this is done where the system is active, the time it takes to do the initial synchronization is really dependent upon network infrastructure, speeds, target system's ability to write, and also the read-write behavior patterns of the source system. What's nice here is that unlike other solutions where it's a cold cutover, cold replication, the system is live and active. With our migrate license, it's 60 days plus, depending upon what your purchasing needs are. So you have plenty of time to perform the migration. Look at the bottom of the screen here. I have activated the compression and transmission, so it's not really showing too much right now. Basically 50% compression overall. And another thing to note is that we're also encrypting the data in transmission. So that will actually slow the transmission down because it's using AES 256 encryption on the source side and it's decrypting on the target. So that's a value if you're going to be doing site-to-site VPN, you would not need to use our encryption, but if you're doing public internet traffic, public IP to public IP, then obviously you would need to use our encryption. So what we're going to do is just going to wait a little bit here for this to progress from source to target, then we're going to initiate the cutover. The replication time will be accelerated from time to time, so where it's 3.7% right here. So you'll see it will progress. All right, now we're at idle from Myriad's standpoint, and replication is ready. All this means now is that the synchronization of the data on the source system in its entirety has been moved to the new environment in GCP. Also, it's capturing the real-time changes. If you look at the bottom of the screen here, it shows you that it had 40 gig to move. The compression it enabled, it moved half of that, which is bandwidth reduction and savings. And it skipped 4.8 gigabytes because that information was already there one way or another. So let's look at the target system one more time before we initiate the cutover. So we can go into the target where it has SSM staging, maneuver into here. Obviously, you can see the various data elements that represent that of the source. Okay. Now, what we're going to do from here is that we're going to tell the Carbonite replication to actually initiate a cutover. So I'm going to do one of two things. First, I'm going to initiate it, and then I'm going to quickly jump over to the source machine so you can actually see what we're going to do there. All right, so let's hold tight here and let's jump over to the source. So here's the source. Obviously, we've instructed it to shut down. It is shut off. So understand. So AWS source server is no longer on the network. The only thing that's on the network right now is the GCP Win 2016. Right. So as you can see here, what it's doing is it's initiating a process. So there's a series of tasks that it engages. What we'll see here in a moment, there's some of the statuses going up. But basically what's happening on the target is that it's going to begin to move things around. So data that's in that staging folder would be removed and it would be placed to the location where it needs to be. So if we were to, again, look at some of the staging data here, and going to, you can see we're exporting the registry, importing it back in. We're moving information around. So if I look at some of these data files here, let me go back up one more level and look at the program's system here. All right, so let's go into files again. Let's go into x86. So as you can see here, this information. And now let's go look at the users. The users is where there's information that was on the source and not on the target. So you see all here the SSI, the SQL, and things like that. So let's just dig a little deeper here. Let's go into the Windows location on the target itself. And you're going to see there's nothing here yet, but as we begin to move forward with the system state, that processing would take place. So let's go back to the console. It's going to take a few moments to do its cutover. It's at 11%. We're going to accelerate the failover time. All right, so I'm going to log in now using the credentials from the source system because it has been replaced. So I hit connect here. Now, if you look at the top left here, the RDP session is showing GCP windows. So here we log in. A couple things that you notice right away are the BG info, it's reporting the SQL services, characteristics of the source are there. I click on the managed services. And then from here, we'll go into local settings, and you can actually see the computer name came across the wire. I can go into program files, and here you go. You begin to see all SQL services and all that. Um, and there we go. Everything is filled over. Applications that weren't there are there, and we are done. So post cleanup activities would be to obviously to remove any old system services. Like in this case here would be to any of the EC2 executables, and then also there's a couple executables you would add for GCP. In addition to the license manager for GCP, you would replace the activation code that's on the system with that of the GCP environment. But pretty much all in all, the failover is finished, its process. Um, it's porting back, it can't talk to it because obviously it can't because it's got a different IP address and a different source name and different credentials. So that's it, folks. Hope you enjoyed the short, brief demo.